Subshells, page 53 of our book. Each shell may contain a number of subshells. We said that the shape of an atom is represented here. The nucleus is surrounded by shells that contain electrons. Each shell may contain a number of subshells, which means any shell is divided into subshells, as if each shell is representing a house. In the house, the subshells represent the rooms. Thus, each shell may contain a number of subshells. These subshells are described by letters S, P, D, F, and G. These subshells are described by letters, as we said. Shell 1 is closest to the nucleus, so it takes the most energy to remove electrons in this shell. Here is an atomic structure. In shell 1, the electrons are closest to the nucleus. It's very hard to remove an electron in shell 1 out of the atom. If the electron in shell 1, we need a high energy to remove it. That is because this electron is highly attracted to the nucleus. As we said, the electron is carrying a negative charge, and the nucleus is carrying a positive one. And you know the positive and the negative do attract each other. As the electron gets closer to the nucleus, there is more energy needed for the removal of this electron. This table now shows you how many subshells there are per shells. In shell 1, there is one subshell named S. For naming subshells, we must put a number of shells. So 1 is for shell and S is for subshell. In shell 2, there are two subshells, S and P. We put 2 to tell that the subshells are present in shell 2. In shell 3, there are 3 subshells, S, P, and D. The same thing happens. We put 3 to tell that the subshells are present in shell 3. In shell 4, there are 4 subshells, S, P, D, and F. We put 4 to tell that the subshells are present in shell 4. Within a shell, the subshells have different energies. With electrons in the lowest subshells being closest to the nucleus. Let's take an example, shell 3. We have subshells F, S, P, and D. These subshells are of different energies, as we said before. As we go from S into D, the energy increases. Now we are far from the nucleus. S is the nearest from the nucleus, then P, then D. S has the lowest energy, then P, then D. We go from S into D, so the energy increases. Thus, we go far from the nucleus. Each type of subshells contains one or more orbitals. What's an orbital? An orbital is the region where the electrons are most likely to be found. Which means an orbital is a region where the electrons may be found. Each subshell contains a number of orbitals. For example, there is one orbital in subshell S, which means there is one region that the electrons may be found. Let's talk about shell 2. It has two subshells, S and P. S has only one orbital. P has three orbitals, which means we can find electrons in three regions. Shell 3 now. It has three subshells, S, P, and D. S has one subshell. P has three orbitals. D has five orbitals, which means we can find 5 electrons in 5 regions. Shell 4. Shell 4 has 4 subshells, S, P, D, and F. We have said S, P, and D. F has 7 orbitals, which means there are 7 regions that the electrons may be found. Thus, each shell has subshells. These subshells have a certain number of orbitals. As n increases, the energy gap between successive shells gets smaller. As a result, the orbitals in the neighboring shells may overlap. We have seen in the previous videos n is the number of shells. As we go through shell 1, 2, 3, the shells are closer and closer to each other. As we can see in this picture, the orbitals in the neighboring shells may overlap. Here's a picture. Here's shell 1 that contains subshell S. Here's shell 2 that has subshells S and P. We notice that P has higher energy than of S, and P is farther than S from the nucleus. Shell 3, it has subshells SP and D. Here's S, here's P, here's D. Shell 4, it has S, P, D, and F. Here's S, P, here's 3D. The shell 3 is overlapping with shell 4. Because the energies of shells 4 and 3 lead to the overlapping of subshells of shell 3 with subshell of shell 4. Thus, if the number of shells is high, the subshells may overlap. As energy increases, the chance of overlapping also increases.